Cool. So, hello. Welcome to week one of our CAD and 3D printing milestones course. This particular section is being taught by the American Society of Mechanical Engineers. So, I'm a student just like you, along with my two wonderful TAs here. But yeah, let's just get started. So, yeah, that is me. I obviously need a haircut. But yes, my name is Andrew Pham. I'm a junior in mechanical engineering right now. I'm from Palo Alto, California. If you guys are from the Bay Area, you probably know where that is. I've been CADing for, at least 6 years at this point. I started in high school. I love the design process. It's a lot of fun. I hope you guys like it too. I do a lot of 3D printing. I'm a 3D printing enthusiast. We'll be talking about that later, of course. And a fun fact about me is I'm a barista that doesn't like coffee. So when I'm home for the summer, I'm a barista, but yeah, I don't drink coffee. Here are a couple of my projects that I've done over the years. And honestly, after this class, you could probably do something like this with a little bit of work, maybe like a little bit of YouTube help. That always is very helpful. But this is something that is achievable after some practice. Yeah.
My name is Amrit. I'm a sophomore at ME&IE. I'm from New Delhi, India. I've got about 2.5, 3 years of experience. I wrote 2 years just so the things I remember, but I was learning about 2D CAD before that. And a fun fact, I know how to make auto blocks in the dining course. So if you all like that, hit me up. I'll give you the recipe for it. That's about it.
Hey guys, my name is Frederick Seddon. I'm currently a freshman at FYE, transitioning to mechanical engineering. I'm from Indianapolis, Indiana, so not too far away. I've got about 2 years in CAD experience, did a class in high school as well. And I helped to run the Gear LinkedIn page. So if you guys ever want to check that out, I write some things on there. And I'm also left-handed, so.
Yeah. So again, me and these wonderful TAs are here as a resource for you. So feel free to ask questions at any time. We're happy to help you. That's what we're here for. So yeah, we're just gonna jump right in. We're gonna start by downloading Fusion 360 because this usually takes a while. So this class was structured on Discord, so there's no bright space or anything. All the resources are through the Discord that we have. And the nice thing about it is once you finish this class, this will be a resource for you like forever, or if you get banned from Discord, sorry. But yeah, you guys can access all this material once you finish this course, which is going to be really nice if you ever want to reference it later. But basically, we're just going to start right here. So if you go under resources and you click on this link down here, we have Fusion 360 installers for you to download just because we can expedite the process of creating an Autodesk account. We're going to be doing that in a minute, but we want this to start running as soon as possible so we can get you guys on CAD. So you just click on this folder. It's a Google Drive. Up here, depending on which machine you're running, download it for Windows or Mac. Yeah, and you just run it. Everyone good here? I'm assuming it's self-explanatory. Okay, awesome. Is anyone having trouble? Or like, has anyone not gotten on the Discord yet? Okay, awesome.
Again, show of hands, people who already had Fusion 360 and have an educational license. Okay, all of you have educational licenses. So you got it.
Okay. So, does everyone have the installer running? All right, cool. So with that out of the way, I'm just going to talk a little bit about this course while it starts to install itself, and also a little bit about ASME. So what is Fusion 360? So you're all here to learn CAD, right? But we choose Fusion 360 because it's free for all Purdue students, which is really nice. It's pretty intuitive and user-friendly, especially for beginners. but it has a lot of advanced features as well, which is cool. And then also it's cloud-based. So if you've ever had any projects in class where you wanted to design something with your fellow students, Fusion is a really great platform to do it on because you can basically make like a Google Drive with your project and all the stuff that you have on there. So yeah, that's why we like Fusion. Also, there's a bunch of other courses in Milestones that utilize Fusion 360. So if you like this course, we have a bunch of other stuff that goes more in depth with like FEA, like load simulation and stuff like that, and a couple other courses. So if you're interested in that, feel free to take a look at those classes as well. So yeah, what is Milestones? So again, a lot of you have registered through Milestones. So, we do a bunch of skills-based workshops where, we want you to get hands-on experience. It's supplemental to your coursework. And then upon successful completion of this, you will get a digital certificate that you can put on your resume or your LinkedIn so you can flex on all the employers that you know how to CAD, and they'll like that. It will take a little while for you to get your certificates, if and hopefully when you pass this course. So don't worry, they're coming. They usually take a couple months to get certified and stuff like that. I wish it was faster, but don't freak out if you don't get it right away because they will come. It just might take some time. But yeah, they will come, don't worry. So some objectives for this course is for you to understand the importance of CAD and why it's really useful. And then we want you to have the necessary tools to be able to make your own model on your computer, right? At the end of the day, like when you go to CAD something, you want to take something from your mind and create it on the computer. So that's our goal. Hopefully you'll be able to do that by the end of this course. We're also going to teach you how to render to make your designs look nice and pretty. And then we're also going to dabble into some 3D printing if you're into that. So a little bit about ASME. Again, I'm a part of ASME teaching to you, but ASME is a huge national organization. We also, have a club here at Purdue, and we're here to prepare our members for success in the industry. That's what we like to say. We want to help you land like big internships. So if you're looking for that, feel free to join ASME. You also don't have to be an ME to be an ASME. That's just call ourselves that, but anyone's welcome. We do a lot of different things. Of course, you're doing something related to us now, but we also have a bunch of other things. We have like small projects, which I'm a big fan of. I think right now they're making like a Mario Kart game, which is pretty cool. But in the past, we've done like battle bots and stuff, which I was a really big fan of. But yeah, we have a bunch of different stuff. There's like too many to name here, so I'm just gonna kind of go through these slides. But if anything is of interest to you, feel free to check us out. It's a pretty cool club. I've been in it since I got here at Purdue. I'm having a great time. So yeah. Also, there's a couple like new design teams that aren't on here. We have like a rover team that's making a rover, which is pretty cool. But yeah, that's new and it's not on this slide. Again, we do professional development. So if you want help with your resume and stuff like that, we do that too. So yeah, if you want to join, there's a QR code. Again, all of these slides are in the Discord. So if you guys don't get a chance to scan it or you want to scan it later, you guys can do that. I hope this QR code works. But yeah. Oh, yeah. Okay, cool. It's kind of old, or this slide is kind of old. But yeah, we have a lot of different connections, Okay, if you're interested, just send me a DM and I'll send you the invite. Sorry about that. But yeah, more about the course. This is a 5-lecture course, so we'll be meeting here 5 times. This is obviously the first time, so hello. we're meeting every Tuesday at the same time, 5:30 to 7:30 p.m. Between these dates. I think the last class is like the week before Dead Week, so hopefully that's not too bad for you guys. Again, if you guys have like scheduling conflicts, please just let me know. Fill out the absence forms. It's not a big deal. Just like please turn in stuff and then you will pass. But yeah, we have 5 modules, for each week. Today we're gonna do a slight introduction after we get all this fusion stuff figured out. And then we're going to be going into intermediate stuff, like, different constraints all the way to assemblies and all that fun stuff. Again, this is kind of a breakdown of what we're going to be doing over the next couple weeks. I'm pretty sure these points are up to date, but basically you need a 70% to pass this class. So it's a pass-fail. So as long as you're above 70, you're good. Again, please just turn things in, because if you turn things in and you show me that you're doing it, I'll probably give you a good score. Especially because I do like 30% or more than 30%, like 60% of the assignments in class. So there's going to be a lot of live demos for you guys to walk through. And again, this video is being recorded, so if you don't catch it right away, you can watch the video in your free time and catch up if you need that, or we can help you on the Discord, right? So we want to give you as good of a chance to get above 70 as you can. And I'm happy to say that like 90% of our students pass. I think that was our metric from last semester. So I really hope that you're part of that 90%, and I hope that 90 becomes closer to 100, if not 100. But yeah, 70%, please turn your assignments in. You'll do great. Don't need to worry. I'm going to be doing most of this. Also, you will have a final in this class, but again, don't worry too much, because all the skills that you're going to be learning in these classes over the next few weeks will tie into your final. You should be able to do your final after like the 2nd or 3rd week. So don't worry too much. The final is not something to be scared of, but mostly as a chance for you to test your design skills, to see how much you learn. The main thing I like to say to students in this class is that you get as much. I always forget. You like whatever amount that you put in is the amount you get out, right? So if you want to put minimal effort and like barely pass the class, that is a possibility. But I highly encourage you to test your skills. Again, this class is not supposed to be rigorous because it's beginner friendly. But if you want to challenge yourself to create something really cool, I would love to see that. So again, I hope you do your best, but if you're really like constrained for time and you just need to turn an assignment in, just do it, and that's okay. So yeah, your final cannot be the engineering fountain or a plane, just because those are 2 assignments that we kind of do in class, and please don't do that. Also, you'll have a chance to have your final 3D printed. So I'm going to be 3D printing the finals from last session, like this week. I'm kind of excited to see them. But yeah, you will have a chance to have proof of your work once you finish this class. It's pretty fun. The only constraint is that you must have at least 5 design features, but you'll learn about that later. So if you don't know what I'm talking about, don't worry. These are some of my favorite final projects from past semesters. There's some pretty advanced stuff in there. Again, this is not the expectation of like you to be in like a CAD god once you like leave this class. But if you want to challenge yourself and create something really cool, I highly encourage it. Maybe your photo will be here in the next session. Don't know. But yeah, these are pretty cool, and I really liked seeing them at the end. So yeah, did everyone's Fusion like install yet? Okay, raise your hand if it hasn't. Is it just like loading, or is it like not? So now that you've downloaded it or it's downloading, you're gonna need to create an account, just like Google Drive or anything. So if you go under resources again, there's this Autodesk registration website. I already logged in, but if you haven't created an account, it'll ask you to create one. Please use your email address. If you don't, then it won't think that you're a student. It'll lock you out and you won't be able to do stuff. So please use your email. Yeah. Is anyone having trouble figuring this out?
Please use your personal ID only, otherwise you will not be able to secure the education license and you'll have to get another account. Questions? Any other questions? Do you have an education license on it? Anybody else have any questions?
So for those of you who might be having trouble obtaining your education license, I'm just going to do a quick rundown of how you do it right here. So of course you want to sign in first after you've made your account. Um,
So what we're showing here right now, if everybody can read here, if you have your trial ends in 30 days written on your Autodesk, please follow this. Sign out of your Autodesk if you have like a trial ends in 30 days message on your top bar. Sign out of your Autodesk and then follow these steps and sign back in. And for everybody else who does not have, who just have set up their account and does not have an education license, just follow it. But again, people who have trial ends in 30 days or trial expired on your Autodesk Fusion 360 top bar, the application top bar, sign out of the application, and then follow the steps and sign back in, and you'll be fine.
yeah. So you want your products and services page to look like this, because if it doesn't look like this, then sometimes you won't be able to like log in and use Fusion. If yours does not look like this, sometimes like randomly they'll ask for further verification that you're a student. Just basically making sure you're not like stealing Autodesk accounts. So down here they have a chat bot and it's like an AI thingy. So if you click on it, it'll like launch this chat window and it'll help you like verify your license. So I first start by clicking education and trial support because we want to fix that. And then software for students, teachers, and schools. And then you need to say, I need to renew my education access. And then it'll spit out a link for you. Click on the top one, it'll open a new tab. You want to scroll down here, and then you see this get products. I don't know if you can see that. Wait, I can zoom in. Yeah. But if you see this get products hyperlink, you can click on it, and then it'll ask you to like verify. Yeah, I mean mine already did it, but it'll ask you to verify some information. So basically, it'll ask you like when you're graduating and stuff like that. It'll also ask you the address of your school. Uh, so you want to use this this address right here. So 610 Purdue Mall. I'll just copy paste it so you guys can do it too.
It might also ask you for your school website as dispurdue.edu. That's it.
Okay. Does anyone need further clarification on this stuff? I know it's kind of confusing. Again, it's not your fault. It's kind of random.
I'm gonna use networking or process. Would you guys? Anybody else have questions? Yeah. Anybody else have trouble?
Okay. Raise your hand if you're having like problems with your licensing. Is no one having problems? Okay. This is the first time that no one has ever had problems. So this is a win. That's true. I really hope that they have good eyes. It will, but if you have the education license, it should work. Last time I let my trial expire and then it just changed to education license. So I hope that works for people with trials, but if not, whole log in, log out, uninstall, reinstall usually works. Yep, basically. Okay, cool.
I'm assuming most of the people have downloaded it and have an education license, if not that top art.
Yes, I'm gonna assume so too.
Okay.
Okay, so now that we've created the account, I'm just going to talk a little bit about the origins of CAD and kind of where this comes from. And then we're going to be doing live demos and you guys are going to do stuff today. So, what is CAD, right? Basically, what we're using, or CAD stands for computer aided design. So, back in the olden days, people would design things on pen and paper. They would have like a room full of people with like these giant easels and rulers and stuff like that, and they would draw and measure things out, and then they would design things and stuff like that, right? But with the advent of computers, uh, that slowly became something that everyone can do on their laptop, right? So a long time ago, some smart dude at MIT invented CAD on this giant computer. It's probably the size of like a room or something, but now we have laptops that are probably like 300 times or more powerful than this dude's room-sized computer. So we can do them on our laptops, and I can teach you today. So that's pretty cool. Of course, there's a bunch of different applications for CAD. Most of the things that you're looking at around this room are or were CADed at some point, right? So like the desk that you're sitting at, the chair you're sitting on, they were probably designed by some dude, maybe not Fusion, but like some CAD software designed the thing that you're looking at, right? All your computers, all that stuff is all CADed before production, right? Um, the great thing about that is, you know, you can do a lot of different things, especially with Fusion. You can do like stress analysis on your designs. We won't be going into that, but it's pretty cool. So you can like test things before making them in real life. So this is like a piston for like an engine, if you know what like goes on inside those things. But this FEA like analysis shows kind of like the weak spots in the design where that part is likely to fail. And that's all with the help of CAD, right? Um, it also allows you to visualize what you're designing in front of you. And with a computer, most computers are powerful enough to make it pretty quick and easy. So I talked to somebody in this room about this, but we're doing Fusion 360, or we're teaching Fusion 360, but there's a bunch of different CAD programs out there, and they all basically do the same thing. I just think that the buttons are shaped differently, and they're all in different places or like hiding somewhere. So they all basically do the same thing. There's a bunch of them. I haven't even listed all of them here. But the cool thing is you can use the knowledge that you learn from this class and apply it to other CAD programs. Uh, so I originally started learning to CAD on SolidWorks, which is the one over here. And I mean, I like it a lot, but when I went to teach this class, or when I took this class, I sat down and I basically converted all my SolidWorks knowledge into Fusion 360 knowledges. Can't talk. Fusion 360 knowledge in like an hour, right? So once you learn Fusion, you should be able to do other CAD programs fairly easily as well. It may not be as smooth for a little while, but you can navigate and make things as well. But yeah, now that that's all out of the way, we can do the demo. So we're gonna start with making simple building blocks, right? Basically, this is going to teach you the fundamentals of how CAD works. the idea is that you're going to take a 2D sketch that you create, and then you're going to extrude it into 3D space, right? So for this cube here, we're going to draw a square, and then we're basically going to pull it into the third dimension so we get a cube. Does that make sense? Does that make sense? Yeah? Okay, cool. So let's get started. So when you open Fusion 360, I'm assuming you all have it open now. You guys need to create a team if you haven't already. It's just kind of your personal workspace, kind of like a Google Drive or something like that. You can name it. But over here, this big blank canvas is where you're going to be creating all your designs, right? This is kind of where everything starts. Right here is your origin, this little gray dot. If you don't have the grid lines and you want to see them, you can click on grids and snaps on the bottom, and I think it's layout grid. Yeah. So if it looks blank like this, you can make the layout grid. Makes it easier to see, but that's just my opinion. So yeah, navigation wise, you can zoom in and out to make your design smaller or bigger. You can pan left to right. Let me I wrote these down. I always forget. So yeah, zooming is like scrolling. If you click on middle click, you can pan, so you can spin around your design. But there's not really a design right now. And then the other thing is orbit, right? So orbiting is what I just did. You can kind of spin around, but panning is like moving side to side. Again, this is why we recommend a mouse, because it makes it a lot easier to CAD. I was really smart and I forgot my mouse today, so please bear with me. But yeah, I recommend using a mouse. You're going to see that it sometimes gets annoying, but I kind of cheat because I have a touch screen, and that makes it a little bit easier. So yeah, get a mouse. I recommend it. You can get like a $5 one. Oh, it's okay. I appreciate it. I'm just gonna use a touch screen for today. But yeah, you really want a mouse with a middle click. A lot of CAD programs like to use middle click. So like those Magic Mouse and like stuff like that don't really work very well. So yeah, just get one with a middle click and you should be fine. But yeah, that's basically how you navigate Fusion, your workspace. My computer's lagging. This is great. So yeah, up here on the top is your toolbar. You're going to be using it a lot to access the different tools to create your designs. Over here on the left is the data panel, which basically, if you click on it, it looks like a Rubik's Cube. If you click on it, it'll open like this side panel, kind of like a Google Drive. So these are some of the past assignments that we did in last session. You can create folders and stuff like that to organize it however you like. And you can also share these designs with other people because it's cloud-based. So yeah, I'm just going to close this right here, and we're just going to start. So to create your design, you always want to start out with a sketch, or you basically always start with a sketch. So up here on the top left, there's this sketch tool. And the nice thing about Fusion is if you hover over a tool for a little while, it'll kind of give you a rundown of what that tool does, right? So if you're ever confused and you don't know if you're going to use the right one, you can hover over it and it'll kind of tell you what it does. So what this sketch will allow us to do is it'll allow us to draw on a 2D plane, and then we can use that sketch and manipulate it to create the object that we want. So I'm going to start by creating a sketch, and you'll see these orange or yellowish orange planes will appear. Basically, because you're working in a 3D environment, you need to select a plane to base your sketch off of, right? So when you're starting with nothing, it'll give you these 3 planes to work off of. Later, we're going to teach you how to create other planes. But another good thing to know is that you can create sketches on things you've already made, right? So if I created a cube and I wanted like a small thing to extend out of that cube, I could create a sketch on the face of the cube, and then it'll allow me to like do other things on top of it, if that makes sense. But for now, we're just working with an empty space. So I'm just going to select one of these planes. This one is the top plane, and then it'll kind of fly and snap into the space that you clicked on. So now that we've entered the sketch, we can start to create our design. So over here, I'm going to start with this cube over here. So to do that, I'm going to select the rectangle tool on the toolbar. So up here, there's this 2-point rectangle tool. And I like to start on the origin. In my opinion, it's really good practice to start your sketches on the origin, or just have something connected to it. Because when you create something, the origin is the only like defined point in space that you're working with, right? So if you place your design on the origin, it'll kind of know where it is, and that'll be really helpful later when we do constraints and stuff like that. So I'm going to click on the origin. You can see I can drag out and create this rectangle. And then, nice, you have a rectangle. Is everyone following here? Yeah? Okay, cool. So now that we have our rectangle, you want to define a length, right? The cool thing about CAD is you can be very specific about geometric shapes, and you can be very precise, right? So up here, there's the sketch dimension tool, and we can use this to define different things. So you can use it to define lengths, you can use it to define angles, you can use it to define like distances between different points and stuff like that. But today I'm just going to do lengths. So over here, I'm just going to click on this vertical line. I'm going to drag this out. And you can see it has like this number, right? It'll give you like an arbitrary number at the beginning, but once you click on it, you can specify it. So let's say I want this to be 100 millimeters, right? Also for units, if you're ever curious, I do not really care what units you CAD in, because I don't really check dimensions on your assignments. There's only one assignment that I really care about dimensions, and that'll be like next week, I think. So don't worry if you're CADing in millimeters or inches. You can CAD in miles. I don't really care, except for your final. Don't do that because I don't have a 3D printer a mile long. But yeah, they don't matter. A lot of these assignments are really open, so you can be creative to create your own designs. So yeah. But yeah, I'm gonna set this to 100 millimeters. So you see the rectangle changed a little bit. I'm gonna select this edge, and I make this 100 as well. We're gonna go over geometric constraints next week, but there's a quote-unquote more efficient way of doing this, but you'll see next week. But for now, I don't know how good the colors are showing up, but you can see how the lines on the rectangle are black, right? So black basically means that it's fully defined. So all the points in space for the rectangle are fully defined, which means I can't move them. So like if I created another rectangle over here, you can see that it's blue. And when it's blue, it's not defined, right? And you see this is partially because it's not on the origin. So you can see how like I can manipulate this rectangle however I want. I can just like stretch it out and it doesn't really care. That's great when you first create your sketch, but in the end you want it to be fully defined. So you know that you can change certain parameters and it'll change predictably, right? So if I had something with like one blue line, that means it's not defined, and that means it's not precise, basically, if that makes sense. So generally, the rule of thumb is to keep things nice and black. You want everything fully defined. The other thing to note is that inside the rectangles, you'll see that they're a light blue, and that also means it's a closed body. So the light blue on the inside is usually a good thing, because it means that it's completely enclosed and it'll allow you to extrude from that spot. For example, if I like cut this line away, you can see that this rectangle isn't highlighted blue anymore because it's not a rectangle. And that means it won't let me extrude it and it won't let me manipulate it in 3D space. But yeah, that's kind of the basics. Make sure all your lines are defined, and when you want to extrude and stuff like that, make sure everything is fully enclosed with the light blue. But once you're happy with that, there's this big check mark on the top right, which will allow you to finish the sketch. So you exit the sketch, and then it'll allow you to manipulate it. So you can see the toolbar changed, and I can go up here, and I can extrude it. So again, if I rotate this, you can see I've just made a rectangle, right? It's in 2D space, but now we're going to make it 3D. So next to the sketch button is the extrude button. It'll think for a second. It'll usually auto select for their first sketch, but sometimes you'll have to specify. So usually like you click around on what exactly you want to extrude. So it'll usually start like this, and then you can like click on it, and then it'll turn blue. Over here, there's a bunch of different parameters that you can change. Start here is basically where you want the extrusion to start. So in some special cases, you might want the extrusion to start away from where you drew your sketch. So that's where you can change it over here. But we're just starting from profile plane, which means it's starting from where you made your sketch. Direction is one side for this in this case, because we're just making it extrude one side. But there's like two sides and symmetric, but we think we're gonna go over that later. Extent type. We're using distance right now because we don't really have anything to relate it to. But if you want later when you're making stuff, like two things to be like flush with each other, you can maybe have it like extrude up to a certain surface. I don't know. You'll see. There's a bunch of like different tools you can use, and you're gonna start to implement them the more you learn. But for now, we're just gonna change the distance, right? So the distance is basically how much you want it to extrude. So because I want a cube, the other two sides were 100 millimeters, so I'm making this 100, and then it'll give me a preview. So yeah, that's a cube. I like it. I'm gonna press enter, or you can press OK over here, and you have created your first object if this is your first time CADing. Does that make sense? I know I talked a lot, but I'm giving you like a foundation so you can kind of understand how this all works. So now that you know how to make a cube, it should be pretty easy to make a bunch of different shapes, right? Sorry? Delete something? What are you trying to delete? Anything. Okay. So if you want to help her, okay. Yeah, what's up? Okay, so now that you have your cube, we're going to work on the cylinder, right? So again, we're going to create another sketch. I'm just going to make it on the same plane that I used before. It'll snap into place. I'm going to zoom out a little bit. And now I'm going to create the 2D shape of the cylinder. So for this, I want to create a circle. So I'm going to be a little bit like quote unquote wrong because I'm just doing it for demo purposes. You know, when you're making parts, you usually do it individually and you'll start at the origin. But for this assignment, we're just doing a bunch of blocks. So it's just one thing. So I'm drawing it away from the origin. I'm going to start to dimension it and define it in space. Let's make this 150. And you can see like the circle itself is defined, right? Like I can't make the circle bigger, but because it's not at the origin, it's blue. And it's because the circle isn't defined in space. So I need to specify how far this needs to be away from something. So I'm going to specify maybe this to be like 200 from the origin. But you can see it's still blue, right? And it's because even though it looks like it should be defined, it might trick you because I can still move it in this direction, right? So to fix that, we need to add another constraint. My computer is very light. I'm gonna give this like a 50. I'm gonna change this. But generally, the rule of thumb is like 3 constraints usually will constrain it in space, right? If that makes sense, like 3 degrees of freedom, 3 dimensions, or 3 constraints. So now it's fully defined, right? So this is defined in like the x and y with these 2 constraints. And then the radius or diameter is defined with this one, right? So again, it's fully defined, it's black, it's fully enclosed, it's blue on the inside. I'm going to finish the sketch. I'm going to extrude it like last time. Maybe let's do 200 this time. And you can see we have a cylinder, right? Everyone good here? Okay, yeah. So, okay, this is also a good time to show that you can go back and edit stuff. So let's say I'm not happy with this cylinder and I don't like how small it is, right? Let's say I want to make it bigger and I want to edit the sketch. Down at the bottom is your timeline. So your timeline is basically the story of how you made your part, or in this case, multiple parts. It's good practice to try to keep your timeline as clean as possible, because you don't like if someone's telling you a story and they're just like jumping all over the place, like that's kind of annoying, right? Or at least it is for me sometimes. So if you can keep your timeline clean, it'll help somebody who's looking at your part understand how you did it better. It's kind of like reading. If yeah, so like over here, you can see the first one is a sketch, right? And then I extruded it with this one, and then I created another sketch and another extrude, right? So it kind of goes in order of how you do it. And the nice thing is you can go back and edit them. So to edit it, usually you're going to be editing sketches. So over here, I'm going to select my sketch, which is the one before the second extrude. I'm going to right click it and click edit sketch. You can see it goes back into the sketch and now I can change stuff, right? So I could change this to like 250, maybe I want it farther away. Or if I want this to be bigger, I can change this to like 200. And once I finish the sketch, all the changes will be applied and you're gonna have a great day. Again, if you wanted to create more constraints, you can use the sketch dimension tool up here. Yeah, you get that over there? Okay, cool. But yeah, I'm gonna finish it, and then you can see the cylinder is bigger now. And the cool thing is, once you have like a really complex part, if you CAD'd it in a really like good way, quote unquote, you can go back and change something really early on, and then it will affect everything that goes past it, right? So sometimes it might break things and it'll ask you to fix it. But other times it'll take all the other things that you added on and it'll run with the design change, right? And it's really cool. I will say that in future weeks, I'm going to ask that you submit your screenshots of your homeworks with the timelines, because sometimes I want to see like the process in which you did something. So being able to see the timeline is a good indication of whether you're kind of grasping the concepts that I teach. So yeah, please submit your timelines. I didn't really go over how to submit homeworks. Basically, you're going to be submitting screenshots on Google Forms. So you're going to screenshot all your assignments. You're going to submit them with your in a Google form with your email and stuff like that. And then, yeah, that's how you're going to do it. So please keep your timelines visible so I can see them. If not, I will deduct points after, I think I said week 2. So yeah, please do that. You can start now, it doesn't hurt. But yeah, is anyone confused on like going back and changing things? No? Okay, cool. The other cool thing about this is you can actually use this bar on the end to like suppress certain features that you've created. So in the future, like if you had like a fillet or something that you wanted to remove for some reason, you could either like delete it physically or you can like suppress it or like hide it. So if you move this little gray bar back and forth, it will change your timeline and it will only display everything to the left of it, right? So I just hid the cylinder, and if I push it forward, then the cylinder comes back. It's also cool when you have like a really complex part, you can press the play button and it like will be like a time lapse of you making the part. It's kind of fun to watch, but we only have 2 things, so I'm not going to do that. But yeah. Moving on, we're going to create this little bridge toy. I'm going to create another sketch. I'm going to choose this face, and I'm going to start with a rectangle. For me, again, I'm starting at the origin because it's good practice. I'm also going to hide the other things just so you can see better. If you ever want to do that, over here on the left, you can like hide bodies or show sketches, which can be useful in some circumstances. But yeah, I'm going to create another rectangle. I'm going to dimension it. I'm going to define it in space. Bam. All right. So that's kind of a simple shape that we're going for. But you see we have this little cutout that we want to do here as well. So generally I like to do things like I like to start my sketch on something that's has a lot of different features on it. So you could go and like extrude this like horizontally and then cut out the cylinder or the arch. But you could also just make the arch in the first extrude, right? Again, there's no like wrong way of doing it, but there are more efficient ways of doing it. So in my opinion, this is a pretty efficient way of doing it. Everyone has like their own kind of style of CAD. It's kind of like, having a style of writing or something like that. Everyone might be a little bit different, but there are generally good practices to follow. So again, I'm going to try to create this arch feature with the extrude, because then it'll only be one operation and then it'll clean up the timeline. If that makes sense. Yeah. All right. So to do that, I'm going to create a circle over here. I'm going to kind of draw it on the center of this line. It'll kind of snap into place. I'm going to define it. So let's call this like 200. And you can kind of see the workings of this arch here. But we also have a bunch of extra lines that we don't really want. So we can go and cut these away. So up here, there are these scissors or the trim tool. Click on it, and you can start trimming away. You can either like hold down and like drag, and it'll like draw like a line, and it'll like cut away. But you can also like click on certain things. It usually like highlights the thing that you're gonna cut away in red, and then when you click on it, it cuts away. You'll also notice that when I did the cut, the arch turned blue, and it's because we deleted the line that it was like constrained to, if that makes sense. So to do that, or to fix that, you can see this can slide back and forth. So to fix that, I'm just gonna constrain it. This is kind of like what we're gonna be doing into week 2, but I'm gonna constrain this geometrically. So I'm gonna take this line and this line here, and I'm gonna set them to be equal to each other without using the dimension constraint. So I'm gonna hold shift, I'm gonna click both of these lines, and then you can see up here there's this big equal sign, right? So I'm going to set them equal to each other, and then you can see the arch snaps into place. It's nice and centered because these two lines are both the same length. Does that make sense? We're going to be going over this more in week 2, but I'm giving you a sneak preview because it's kind of fun. But again, you can see the section that I want to extrude is blue, so I'm happy with that. I'm going to finish the sketch. I'm going to show the bodies again. You can see how, like, for this particular circumstance, I drew the block on the cube, and let's say I don't want them to be touching, right? So I'm going to go to extrude it like I normally do. In this case, because there's like multiple overlapping sections, it'll ask me to specify. So I'm going to select these two to select the whole block. Over here, instead of starting from the profile plane, I'm going to use something else. So I'm going to start with an offset, which basically will allow me to start the extrusion away from where I drew it. So let's just give that like, I don't know, 50. And you can see the arrow moved a little bit. And then for the distance, I'm going to specify maybe like 100. And you can see how this blue like outline is where I drew the sketch, but you can see how the block is not touching it, and that's because of this offset over here. So it's useful sometimes. You obviously could have drawn this on another plane, but it's a useful tool to know. Yeah, I'm gonna press OK. Gonna solidify the model. That looks good. And we're almost done. So the only other thing is that you see these blocks have colors on them. For a lot of the assignments, we'll ask you to color them. So I'm going to teach you how to do that now. Please don't use gray, because if you use gray, I'm just going to think that you didn't add color, and then I'm going to take off points. So yeah, use bright colors or just something not gray. So to color your things, you can either find the body and right click it and click appearance, or you can just press A. There's like a bunch of different ways of entering it. But over here, you can see there's a bunch of different appearances you can select. This is also useful for when you're creating things. with certain materials. You can specify the material with the appearance, and you can use it to calculate like how heavy something might be or like the center of mass and stuff like that. But for if you press A, it should appear. Sometimes it's like a little bit hidden and it'll be like over here.
Just double click on the shape.
But yeah, in this case, I'm just gonna like color it with paint because I just want it to be colorful. So I'm just gonna choose a color. In this case, I want it to be blue. So I can just like drag the appearance onto the part that I want. So I made the bridge blue, let's make the block green, and I don't know, let's make the cylinder red, right? So you just drag it, the appearance will be applied, you're good to go. Does that make sense? I know I'm going slow, but it's so you understand how it works, because then I can go faster for the other ones, and you can kind of follow along. Everything good? Okay. So for appearances, there's like a bunch of folders over here. Um, so you want to open the folder that of the appearance that you want. In my case, I just choose paint because it's really colorful. Sometimes it'll ask you to download it. So over here, there's the download arrow. And then once it downloads, you can just take whatever appearance, in this case color, you can take it and then you can just drag it onto your part. So let's say I want to make this block white instead. I'm going to drag it over here and now it's white. But yeah, that's your first assignment. If you screenshotted this and submitted it, you'd get 100%. So that's what I'm saying. This class is not super difficult because I'm doing the demos here. You do have homework. I'll go over that in a little bit, but I'll be doing most of them in class. Everyone good?
You'll have the slides as well. The lecture slides and the recording of this Discord, so don't worry about it. That's our incentive, not best at class. And there's
Okay. So I have about 30 minutes to teach you the next assignment. Wait, did I skip one? Oh, I did. Okay, so we have 30 minutes to do 2 assignments. So I'm gonna crank it out real quick. You guys can follow along. Again, this meeting is being recorded, so if I'm going really fast and you guys can't figure it out, that's okay because you can watch this video later. I just want to do the demos in front of you so you understand. Uh, and if I'm going fast, you can watch the video later. 'Cause we only have half an hour. Yeah, I think. Yeah, it's like 7. So I'm gonna go a little bit faster, but hopefully you understanding the fundamentals that I just taught you will help you follow along with what I'm doing. So we're gonna create a hammer, right? Again, there's a bunch of ways of doing it. I'm gonna start by creating a new design. So just like a Chrome tab or a browser, you can create a new design and you can have multiple open at the same time, which is pretty nice. Again, I'm starting from a sketch. So I'm starting from creating a sketch. I'm selecting a plane. So I'm selecting this top plane here. Snaps into place. I'm going to start with the handle. So I'm going to draw a circle and I'm going to create a nice cylinder for us to use. So again, I made it at the origin. So it's defined in space. I'm going to specify the diameter. So I'm going to set it to, I don't know, like 50. I'm happy with that. It's fully defined. I'm going to finish the sketch with that big green check mark. And then I'm going to extrude it. Just like assignment 1. Maybe like, yeah. So that looks like a handle to me. I like that length. It seems somewhat proportional. I'm going to press OK. And we have a cylinder, right? This is the same as assignment 1, but we're adding a little bit, right? So instead of creating just like one simple shape, we can create something more complex by creating features on top of features that we've already created, right? So again, I'm going to create a sketch, and instead of selecting one of these planes over here, I'm going to select the top of the cylinder, right? So if I click on the top of the cylinder, it will snap into place, and I'm going to start drawing a rectangle. Now, this rectangle is a 2-point rectangle, which means that it'll draw like a rectangle corner to corner on whichever place I specify. But sometimes you want your rectangle to start from the center. And that's when you can go under create and you'll see a bunch of other options, right? So you're not limited to just creating like lines and circles, but you can also create like different kinds of circles. You can make special arcs. But in this case, I'm creating like a special rectangle, which is the center rectangle. I really like the center rectangle because I like drawing my rectangle like centered on the origin. So I usually do a center rectangle with the center on the origin, but that's just me. Again, it's like different styles, but I like it. In this case, again, I'm doing the origin thing. I'm drawing a rectangle, and you can see how it's like centered around the cylinder, which is again why I think it's good practice to start on the origin, right? Because I drew the cylinder on the origin and I'm drawing the rectangle on the origin. They're all centered and everything's nice without me having to add a bunch of unnecessary dimensions, if that makes sense. Yeah, I'm going to create this rectangle. Because it's at the origin, I only need to specify like the length and the width and the width. So I don't know, let's make this 300 and make this like 150. And you can see we kind of have like a profile of the hammer that we want, right? I'm going to finish the sketch and I'm going to extrude it. And you'll see on this hammer model, there's a little bit of a cylinder on top of this rectangle, right? And again, there's multiple ways you could go about doing this. You could create the cylinder, which we've already made. You can extrude the rectangle and then create another cylinder on top. Or we can make the rectangle or the rectangular prism inside the cylinder, so it's only two operations, right? So this is like more efficient, but again, it depends on circumstance, right? Sometimes you would want to extrude that cylinder because maybe that cylinder is smaller or something, but in this case, they're both the same size, so I'm just going to have this prism like phase through the cylinder, if that makes sense. Yeah. Okay. So again, just like how we did on this bridge block, we're going to create an offset from the sketch plane when we make the extrude. So again, I'm going to extrude it. It's asking me to specify what I want to extrude. So I want to extrude this whole rectangle, right? It's going to start on an offset, so we can have a little bit of a difference for the top. So maybe let's make this like 20. In this case, it went up 20, which means like the rectangular prism would be floating in the air, but I don't want that. So I'm going to change this from 20 to -20, and you'll see the arrow moves down, which means the extrude will start 20 millimeters down from the sketch plane. The arrow also tells me the direction that it's going to extrude. So if it was going to extrude this way, it's extruding the wrong way, right? This will also cut off the top of the cylinder. At least not Autodesk, Fusion will assume that because you can cut things away. So in this operation, it says cut, but we don't want that either. I'll show you in a second. So instead of positive, I'm going to go negative. And you can see this like red prism is where this rectangle is extruding. But it says cut right now. And it's because Autodesk will, or Fusion will assume that you want to cut away at the cylinder. But you can change that, right? It'll guess, but it's not always right. In this case, we want it to be joined, right? We want the rectangular prism and the cylinder to be one piece. So I like this. I'm going to press join, or I'm going to select join. I'm going to press OK. So now we have our hammer. You can see in the timeline, it's nice and clean. There's two sketches, two operations. It's nice and efficient. You can also see over here that the edges on this hammer are rounded. So that's another operation. So to do that, you can add this fillet over here. So fillets are nice. It makes your things nice and smooth. You're not going to cut yourself. You select the fillet tool, and then you start selecting your edges, right? You select every edge that you want to be filleted. I'm going to go around here. The other thing you can do is you can select faces, and then it will like select all the edges. So I can select this face, and it should fillet every edge as well. Over here on the right, you can specify how big you want your fillet to be. So the larger the number, the more round it will be. So if I do like 5, it's like tiny, and if I do like 20, it's nice round. Just gonna press OK. And there we go. We have a hammer. Again, if you ever want to change things, you can go in your timeline and you can right click your feature like a sketch or an extrude. If you want your extrude to be bigger, you can change that. Right? I edited it and then I press OK. It's a little bit longer now. But yeah, that's your second assignment. Everyone good? I know I'm going a bit faster now, but does that make sense? Yeah. We can help you if you have questions. Yeah. So again, there's multiple ways of doing it. You can create another extrude and make this cylinder, but what I did was I made an offset on the original rectangular prism sketch. Oops. Hello. Gosh. So if you see over here, where it says start, I changed it from profile plane to offset. So that's basically telling Fusion that I want the extrude to start away from the sketch. So you can see the blue rectangle is where I made the sketch, but you can see there's a gap in between here, and that gap is 20 millimeters. I set the distance to the extrude down here, and then I set the operation to join instead of cut to make sure that the rectangular prism combines with the cylinder. Does that make sense? The operation is set to join, so it makes sure that the cylinder and the prism are one piece. Fusion categorizes them as bodies, so it will make sure if you use the join feature, it will combine it into one body. So if you wanted them to be separate, you click new body, but in this case, it's just one piece. Again, the cut feature is very useful if you want to cut things away. So if I changed it to cut, it would cut out the rectangular prism shape out of whatever whatever body was existing right there. But I don't want that, so I'm doing join. Is that good?
Anybody else have questions? No?
We have 15 minutes. and one more assignment to go through. So if you didn't get this, that's okay. I'll stick around a little bit after, but also these are recorded. So if you don't get this today, you can watch the video later. Okay, so over here, I'm creating a new design. I'm creating this game piece from, I don't know, Sorry or chess or whatever you want to call it. But I'm going to be teaching you one new thing today, which is the revolve tool. So we've been extruding things, which is just pulling a sketch and making it 3D. But sometimes you want to revolve something. And I don't know if you guys have taken calculus, but you know, like the cones and discs and washers and stuff like that. That's basically what we're going to be doing in CAD. So we're going to be taking a sketch and we're going to copy it like an infinite number of times until it's a solid piece. So it'll allow you to make round objects, and you can even make like spheres and stuff if you really want to. But today we're creating a chess piece or a game piece. So I made a new design up here on the top right. I'm going to create a sketch. Instead of the top plane, I'm going to select one of these side planes. And then I'm going to start drawing my chess piece. So you can see right here, this is kind of what we're after. You're going to be drawing like a little snippet or little profile of the piece that you want to create, right? So it kind of looks like you're looking at your game piece from the side and you cut it in half, and then you just draw that one half, because we're going to revolve it and then it'll be a nice round solid object. So I'm going to create my piece. Kind of made like an L. I'm going to draw like a circle on top of it. I'm going to draw a line to the top of the circle. And then I'm going to draw a line to here. And then I'm going to draw a circle. So this looks like kind of ugly, right? It doesn't really look like a chess piece, but this is actually all that we need to create our design, right? We're going to just kind of make certain lines line up and then trim away what we don't need, and we should have a profile, right? So for starters, I want this piece or this end of the line to touch this circle. So I'm going to just use geometric constraints. You don't really need to, but we're going to learn this next week. I'm going to make this line coincident, which basically makes sure that it's touching it. Or I'm going to make that point coincident, and then I'm going to make this line tangent to the circle. Other than that, I should be able to just trim away with the trim tool. I'm going to cut away this part of the circle, that part of the circle, and this line. And you can see we're kind of getting that profile that we were after. Now it's just kind of a matter of adding dimensions to what we see fit. So I don't know, let's do, I want it to be like 100 millimeters tall. I want this to be like 15. Oh, I think I added a 0. There we go. I want this to be, I don't know, 50. This diameter, like 20. Okay, so I have this profile. I just added a bunch of dimensions. There's like better ways to do this, but again, I'll be teaching you that later. But we have our profile, right? This is kind of a shape that kind of resembles the side of a chess piece, and now we're going to revolve it and make it a 3D object. So just like before, I'm satisfied. I'm going to finish the sketch. Remember, everything's fully constrained, so all these lines are black. Outline is blue because it's closed. And then I'm going to go and revolve it. So right next to the extrude on the right is the revolve tool. If I click on it, it's going to select this shape. And then you need to specify the axis of rotation, right? So if you have done like the disk and washer thing in calculus, it's basically telling it where the center of that disk is, right? So in this case, it's the middle or like really long vertical axis right here. So if I click on it, it'll revolve it and it'll make our little game piece. And you can see how it works, right? There's that one blue sketch and then it just copies it a bajillion times until it's a nice solid body. Press OK. And there you go. I think the one last thing to put on this game piece is your name or some words if you don't want to put your name. So I'm going to create a sketch on the bottom face. So I'm not selecting these planes, I'm selecting the bottom face of the game piece, and then I'm going to create some text. So if you go under the create drop down, you can see that there's a text feature. It's pretty cool. You can also like make it wrap around like other lines that you've created, but I'm not going to do that today. Test. So you see, I'm just going to write some text. You can change the font and size and stuff like that, but I'm just going to leave it. I'm going to finish the sketch, and then just like everything else, I'm going to extrude it. Oh. Nope. So I'm going to select the text, and you can see the distance is set to a negative number in this circumstance, but depending on where you drew it, it might be positive. This operation is set to cut, so just like I was talking about with the hammer, we didn't want to cut it away, but in this case we did, and Fusion was smart enough to tell me that I wanted to cut it out. So it'll guess, right? It guessed cut and it guessed right this time. And then if I press OK, you can see how the text is like cut into the chess piece, right? So you can do the cut feature with more than just text. Again, you can draw very complex sketches and cut those. But in this case, I just did some text. Just like the first assignment, I'm going to add an appearance again. So I'm going to press A. The appearance bar will show up on the side. Again, sometimes it likes to hide, and you have to press these arrows to make it show again. And then I'm going to make this a green game piece. Yeah. But yeah, those are all the assignments that I'm doing in class today. Again, if you were paying attention and you got all of this, that is awesome. You have done 75% of the work for today's class. You do have one homework assignment, which is to create a chair. Again, there are no like dimensional constraints for this chair. we just ask that it has at least 4 legs, a seat cushion, and something to rest your back on, right? So feel free to get creative and design wacky chairs. But this is your playground. You can create whatever chair you like. Please make it school appropriate. That's all I ask. I don't think that is a very tall order. So yeah. Other than that, that's the end of week 1. I'll see you next week. Thank you for tuning in. Make sure you fill out your attendance before you leave. If you haven't done it already, there's an attendance form. Please fill it out. If not, you're going to get an email from me like tonight or tomorrow getting mad at you for not being in class and then like threatening to drop you. And I don't want to do that because you were here. So please fill it out. Yeah.
Also, if you guys have any trouble with the homeworks and you don't want to ask a question on the homework help, you can DM me. Or if you find trouble in like text responses, again DM me and I can set up a call and we can figure something out.
Yeah.
Yeah. Like, think of it as like office hours on the West.
Yeah.
So, yeah, you can do that. I mean, I'm free. I can take in a couple of people.
Yeah.
At a time. You can do that.
I'm also available if you need that. But yeah, feel free to ask any questions. We're a resource for you. But yeah, that's about it. Thank you. Fish on time. Let's go.
6 minutes early.
Yeah, I'm gonna stick around. If anyone needs help, I will help them out. But then I have to do homework.